सर जब रिक्वायरमेंट ही 11 kV का है फाइनली नेरिस्ट में 11 kV ही क्यों नहीं हो?
I was telling you, usually generation at the generating station, it is usually 11 kV. That is stepped up to 33 kV or 132 kV. Then it is transmitted.
मैं वही सोच रहा 11 ही था एंट्री में, एग्जिट में 11 है, बीच में नोटन क्यों चल रहा है?
Those electric bulbs we used to call, they are filament bulbs. Inside the bulb you will find there will tungsten filament. So that works on the principle of heating effect of electric current. Just like electric heater.
Oh.
Exactly.
अच्छा.
So because of I square R loss, power loss only, but that gives rise to heating effect.
रेजिस्टेंस ज़्यादा है.
Resistance is very high. Tungsten, the resistivity is also very high.
तो वही मतलब फ्लो ऑफ इलेक्ट्रॉन्स का रेजिस्ट कर रहा है इसलिए वो गर्म हो रहा है.
गर्म हो रहा है and that glows basically.
गर्मी का वजह से.
This is one aspect of conventional system, but using renewable energy sources, we are using all power electronic switches, devices. So what happens is this inherent quality of rotating machine, like inertia and then synchronous impedance, these are missing. So what happens is power electronic switches or devices, they have their rated values of current, voltage, power. So if that is exceeded, there can be blackout also. So what I'm trying to say is, if we use more and more renewable sources of energy in future, the grid will be inverter-dominated grid. So this is one aspect. I think people are doing a lot of research on.
This is so different from what the conventional narrative is.
Yes.
That's it.
Yeah.
Hello viewers, so NBT Conversations with it's another episode. Well, the range of playlists that I have for NBT Conversation is very wide. Like I've spoken to sports people, I've spoken to artists, I've spoken to people from Bollywood. But एक जो central core मेरा जो channel का रहा है और रहेगा भी, it's on the education. Especially because I am an engineer myself, तो engineering education पे मैंने काफ़ी ध्यान दिया है. आज भी an addition to one of the videos for that playlist. Today I'll be speaking about very primal, very foundational engineering, electrical engineering. तो सर मेरे साथ है प्रोफेसर सरसिंग गाओ. वेलकम सर.
Thank you.
तो हाउ डू यू फील सर एक स्टूडेंट के सामने आपका स्टूडेंट रह चुका हो एक टाइम पे तो.
No, I feel honored, and then since we are close to each other, we are in the same campus, so I've seen you growing. So it's I feel wonderful today.
All right, sir. So, audience, he is Professor Sarsing Gao, has been teaching electrical engineering courses, I don't know, since last 3 decades or more than that.
Yes, 3 decades.
3 decades.
Yeah.
So, by designation, he's a professor. तो सर आप खुद ही ऑडियंस को बता दीजिए आपका एकेडमिक जर्नी स्टार्टिंग फ्रॉम द वेरी बिगिनिंग सर.
I started my education from NERIST. I got admitted here in base module 1988.
1988.
Yes.
I was just a 3-year-old kid, sir.
Okay. So since then I am here at NERIST, and after graduation I took up lecturership job because I qualified GATE that point of time in 1994. And then I went on to do my masters from IIT Roorkie, then PhD from IIT Delhi.
So which year was it, IIT Roorkie wala?
That was that was 19
याद नहीं है ना सर.
नहीं.
ठीक है सर.
99 to 2001. Sorry, 99 to 2001. I did my masters.
सर मुझे एक और फैक्ट का बारे में पता है कि यू आर द फर्स्ट टेक्निकल PhD होल्डर फ्रॉम आवर स्टेट. व्हेन आई से टेक्निकल आई मीन इंजीनियरिंग वाला. साइंस तो बहुत पहले से था.
Yes.
वो सही है ना सर?
I think so.
बिकॉज ऑन रिकॉर्ड आपसे पहले तो PhD.
That is what I also got to know.
सो कॉन्ग्रेचुलेशन फॉर दैट.
Thank you.
मतलब इट्स ऑन रिकॉर्ड नाउ क्योंकि लोग जानते नहीं इस बारे में बट मुझे पता है कि आपसे आपके बाद फिर PhD होल्डर्स इंक्लूडिंग मी बहुत निकले हैं बट यू आर द फर्स्ट टेक्निकल वन इंजीनियरिंग.
I think so.
तो सर आप मास्टर्स किया 99 to 2001
That
and
time actually 1.5 year master's program was 1.5 year only,
अच्छा अच्छा
not 2 years.
तो you have been a lecturer since as you mentioned
94.
94
Yes.
इसीलिए 3 decades अभी
Yeah.
94 से लेके अभी तक
It is past 3 decades. in
past 3
fact.
decades that's
Yeah.
correct sir sir so when you had I would believe too many options to shift your industry as well ये academics पे ही as a teacher ही क्यों
Academics, actually, the teaching post that point of time was a Group A, classified under Group A position.
Group A
Group A. So, and then this assistant engineer, as a matter of fact, that time was a Group B post.
really
Yeah.
okay
So because of that, I stayed back
Uh-huh.
in this profession, and also I was interested in teaching and research. So that's the reason I mean,
समझ में आ गया सर पहले लेक्चरर पोस्ट ग्रुप ए था
Yes.
एई जो इक्विवेलेंट पोस्ट होना चाहिए था वो ग्रुप बी था
Group B.
तो
Yes.
बाय वर्च्यू ऑफ देयर यू स्टेड
Yes.
बैक और यहाँ मजा आना शुरू हो गया
Cadre, yeah.
फिर मजा आना शुरू हो गया तो
Maza. Exactly, exactly.
So you did your B.Tech from NERIST, M.Tech from IIT Roorkie and PhD from I got a miss-
Delhi.
IIT Delhi.
IIT Delhi.
Alright sir. तो सर अभी क्वेश्चंस पे आते हैं ये तो हो गया आपका
Sure,
इंट्रोडक्शन
sure,
सो इज देयर एनीथिंग एल्स यू वांट टू ऐड इन योर इंट्रोडक्शन सर
Not exactly, but yeah, it has been a very fruitful journey for me. Last 3 decades, I could do research. I could supervise PhD candidates. So 5 PhD candidates I have graduated. So I'm liking it actually.
One of your current PhD candidate has just cracked her APCS AE exam.
Yes.
So congratulations, sir.
Thank you, thank you.
So I mean, you have molded her, guided her, brought her up, and now she is an officer now.
Yes,
अभी तो
yes.
A grade है हो गया ना
हाँ, group A, group A.
पावर डिपार्टमेंट A
Yes.
तो सर मैं अभी जिस रीजन से ये कन्वर्सेशन हो रहा है टू मेक पीपल गेट द अवेयरनेस अबाउट इलेक्ट्रिकल इंजीनियरिंग
Yes.
वहाँ से शुरू करते हैं
Okay, sure.
तो पहला क्वेश्चन हमेशा यही रहता है आपको भी वही स्टैंडर्ड क्वेश्चन पूछूंगा हाउ वुड यू डिफाइन इलेक्ट्रिकल इंजीनियरिंग टू ए 10-year-old kid
Electrical engineering, I keep telling this actually, is an offshoot of physics. Physics, then additionally, definitely we need tools like mathematics, chemistry as well. Because in physics, in the schools also, we introduce electricity and magnetism. So electrical engineering starts with electricity and magnetism only.
Okay.
For example, if we take electric motor, so it is purely based on electricity and magnetism only. And also Faraday's law of electromagnetic induction, that is
So
also taught in the school.
You have to consider me to be somebody who doesn't know anything, even the audience, sir.
Okay, so
आपको मतलब वो भी बताना है मैग्नेटिज्म भी क्या होता है एकदम बेसिक लेवल पे
see what happens is whenever current flows
हाँ
and through a conductor, around that there will be magnetism. So yeah, Fleming's left hand rule, Fleming's right hand rule defines that actually. So and thumb rule also says if current flows in this direction, there will be magnetism around it.
Okay.
So using this concept actually Faraday in 18th century itself, he gave the definition of Faraday's law of electromagnetic induction, which says that if a current carrying conductor is placed in a magnetic field, there will be force developed on that conductor. Yeah, and that is the basic working principle of an electric motor. Now coming to electric generator, if a coil or a conductor is placed in a magnetic field and if mechanical force is applied to rotate the coil, then voltage will be induced in that conductor, or rather EMF will be induced in that conductor. So that's how that is the basic definition of electric motor and electric generator.
मैं एक बार ट्राई करता हूँ प्लीज करेक्ट मी हो
Yeah, sure.
आपने बोला कि अगर फर्स्ट ऑफ ऑल कंडक्टर होगा तभी इलेक्ट्रिसिटी जाएगा, नहीं तो जाएगा ही नहीं. वो clear with-
Conductor is required. Yes.
तो कंडक्टर में इलेक्ट्रिसिटी जाएगा.
Yes.
तो फर्स्ट थिंग यू सेड कि उसका बाउंड्री बोला ना आपने ना, क्या
No.
बोलते हैं उसको?
Boundary means a coil. Basically, it will be a coil.
हाँ, तो उसमें मैग्नेटिज्म डेवलप होगा.
Yes, if current flows through it,
हाँ, वही कंडक्टर में करंट
Yes.
फ्लो करेगा तो मैग्नेटिज्म डेवलप.
magnetism
ये
develop
फर्स्ट स्टेप
होगा.
बोला. फिर आपने
Yes.
बोला कि मैग्नेटिक फील्ड में कंडक्टर डालेगा
Yes.
तो फोर्स जनरेट होगा.
Force generate होगा.
फिर आपने कहा कि अगर हम
But current should flow.
करंट शुड फ्लो, वो
Current
तो
should flow.
बेसिक ही है, मतलब
Yes.
वो फ्लो हो ही रहा.
Yes.
फिर उसी से इलेक्ट्रिक मोटर बना है, वो
Electric
की वजह से वो
motor.
घूमता है.
Yes,
right?
yes.
और फिर आपने कहा कि फोर्स दिया
Yes.
तो वोल्टेज इंड्यूस होगा.
Yes, if that is coil or the conductor is mechanically rotated,
वही फोर्स.
yes, by applying force, then voltage will be induced.
देखिए सर, मुझे अभी समझ में आया एक्चुअली में, हम भी हवा में बहुत कुछ कर देते हैं, ऐसा है. दैट्स व्हाई आई एम सेइंग कंसीडर मी एज अ पर्सन हु डजंट अंडरस्टैंड एनीथिंग.
Okay,
तो अभी आपने बताया 10 ईयर ओल्ड को,
Yes.
तो यही फंडा से लेके यू बिल्ड.
Electrical engineering is developed.
ओके सर. तो जितना हमें समझ में आता है, पर्पस ऑफ इलेक्ट्रिकल इंजीनियरिंग तो लाइट देना होता है ना.
Light then out. Yes. So that generator. I talked about electric generator right now. Just now.
हाँ बताइए सर.
So because when voltage is induced, so that voltage is generated, and if a load is connected to that, then current will start flowing. Suppose the load could be electric bulb also.
ओके, दैट इज
Yeah.
लोड, इलेक्ट्रिक
Yes,
बल्ब.
that is load.
हाँ सर, तो मतलब अभी एक एक करके कनेक्ट कर दिया, ऐसे से ही बिजली मिलता है. यही पूरा कहानी है ना.
Yes. Yes.
तो सर अगर इतना सिंपलिस्टिक फंडा है, इसमें इतना रिसर्च जो चल रहा है, इतना.
No, actually, generation is electricity generation is one aspect, but after that, it has to be transmitted also. It has to be distributed also over a long distance. So there are so many issues coming up in the transmission line itself. There will be so many losses, and that has to be actually addressed. So that is why there are so many devices, equipment that is being used, that is placed in the transmission line also to reduce the losses mainly.
तो सर शुरू करें फिर से स्टार्ट से, इफ यू आर कंफर्टेबल सर.
Sir.
सपोज हाइड्रो इलेक्ट्रिक पावर प्लांट में
Okay.
पावर जनरेट हो गया है.
Yes.
एज आई अंडरस्टूड कि वो आपने जो बोला कि मोशन होगा तो फोर्स जनरेट हो गया,
Yes.
उसका वजह से वोल्टेज डेवलप हो गया. यहाँ के ले लेके मेरा घर तक बिजली कैसे पहुँचता है सर पावर प्लांट?
Exactly. Suppose you take the example of hydropower plant. So what happens is there will be turbine and generator, and in fact in any power plant there will be several sets of turbine generator units.
आर दे कपल्ड? मतलब
Yeah, turbine and generator they should be coupled.
ओके ओके.
They should be coupled. That is first and foremost requirement. So in case of hydropower plant, the water discharge that is coming through the penstock, that will drive the turbine, that hydraulic turbine.
करेक्ट.
And because turbine is rotating, so that is, and turbine is again coupled to the generator, so the rotor of the generator will be rotating.
हाँ.
So when the rotor of the generator is rotating, we call it alternator basically.
Alternator.
Alternator. It is generator only. So then voltage will be induced on the stator windings. Just I explained you Faraday's law of electromagnetic induction. The working principle is exactly the same. So when the rotor means there will be rotor windings. So then the rotor is rotated. That is precisely what I was telling. If a coil is rotated in a magnetic field,
Yes.
EMF is induced.
Induced.
So because the turbine is coupled to the rotor, and the rotor has got rotor windings, and that is also excited from a DC supply.
अभी ये भी क्या है, ये क्या चीज़ है सर बताइए.
No, because there should be magnetism. No?
हाँ.
So to get that magnetism, actually, DC supply is given to the alternator.
डीसी सप्लाई का बारे में थोड़ा बाद में बताइए.
Okay, so DC and that is excitation current actually.
एक्साइटेशन करंट.
Current, yes, that is given in the rotor windings. So because current is flowing, so magnetism is already developed. So because of that, there will be electromagnetic induction. So voltage will be induced on the stator windings. So, and from there we can collect the थ्री फेज वोल्टेज.
हाँ, ये क्या आता है फिर?
Three phase, because alternators will be usually three phase machine. Three phase means three windings.
Three windings.
RYB, there will be three windings which are spaced 120 degree apart from each other. So that is why we are getting three phase voltage developed on the stator winding. Once voltage is generated, that is collected, and then see, if you have to transmit to a long distance, that voltage has to be stepped up.
Okay.
So that is why usually the long transmission line, the voltage will be in the range of say 132 kV, kilovolt, or maybe 400 kV. And nowadays, DC transmission line is also coming up, which will transmit the voltage in order of 800 kilovolt. So that means in the generating station, actually once the voltage is generated, that should be stepped up for transmission.
Step up means उसको बढ़ा रहा है ना?
बढ़ा रहा है, बढ़ाना. So that's how power is transmitted.
यहाँ तक मैं समझ में आ गया कि वोल्टेज हैज बीन जनरेटेड.
Yes.
और उसी को हम वोल्टेज को लेके जाता है, ट्रांसमिशन करता है बेसिकली.
ट्रांसमिट करेंगे. Yes.
आपने जो डीसी सप्लाई बोला ना,
Yes.
वो थोड़ा बताइए क्या होता है डायरेक्ट करंट सप्लाई, मतलब
डायरेक्ट करंट सप्लाई एंड ऑल्टरनेटिंग करंट.
उसको भी बताइए.
हाँ, ऑल्टरनेटिंग करंट
सर प्लीज मेरा सवाल से इरिटेट मत होइए, मैं एकदम बच्चा ऐसा पूछ रहा हूँ सर, क्योंकि मैं चाहता हूँ कि मेरा
Absolutely fine. I'm finding it interesting.
हाँ सर
actually.
बताइए सर.
So, direct current is something which does not vary. Suppose if we plot a curve also, it will be a straight line. Suppose XY axis, and in the Y axis, if the current is there, it will be a straight line.
Understood.
Yes, but alternating current, there will be zero crossing. It will be a sine wave like this. Zero crossing will be there, so it will be alternating. So, in case of alternator, I was telling, DC supply is given as an excitation current.
सर ये तो आपने जो बोला ग्राफिकली जो बताया,
Yes.
ये दिस इज अगेन ए टेक्निकल डेफिनेशन ओनली सर.
Technical definition.
थोड़ा मतलब बच्चों को मतलब
Okay.
फिजिकल डेफिनेशन बताने से एग्जांपल
Physical definition.
जाके समझ में आए, मतलब कोई भी एग्जांपल ले लीजिए सर, मतलब दैट
Now, direct current, usually we get it from battery source.
बैटरी सोर्स.
Battery source, the output voltage or current will be always a DC.
ओके.
Direct current. So, but from a generator, alternator for example, if voltage is generated, that will be AC.
सो अभी भी मैं चाहता हूँ थोड़ा सा और क्या मतलब, और एसी और डीसी के बारे में बहुत लोगों को नहीं पता. आई नो.
Yes.
वो लोग बस थियोरेटिकली बुकिश पता है, कॉन्सेप्चुअली वो लोग दे डोंट अंडरस्टैंड इट. सो आई वांट देम टू अंडरस्टैंड थ्रू यू एक्सप्लेनिंग देम सर. ये बहुत बेसिक हो गया, आप तो इधर रिसर्च कर रहे हैं लेकिन
Yes, yes.
फिर भी सर.
DC, usually we define it like that only, because with the help of, otherwise both are current, but if we have to define them, that is, DC will be a constant.
हाँ, that understood.
Constant, and then
वेरी नहीं
yes,
करता है तो.
vary नहीं करता है, and the other one will be alternating, and
वेरी क्यों करता है सर?
vary.
हाँ, वो जो एसी जो करंट जो.
Vary इसलिए होता है, as I told you, suppose three phase winding.
हाँ.
Three phase winding. What happens is, three phase winding means RYB windings are there, and because the rotor is rotating, so the voltage induced on the stator windings will be that sequentially voltages will be induced.
Okay.
On R winding, Y winding, then B winding. Sequentially.
Sequentially बोला तो थोड़ा समझ में आया.
Yes, that is why there will be a zero crossing also for each phase.
मतलब as you said, three phase है,
Yes.
placed 120 degree apart.
120 degree apart from each other.
कैमरा में ऐसा ना.
Yes, it could be star winding or delta winding also.
वो भी फिर ये फिर अलग term.
Star connected windings and delta connected windings we can have, because finally there are three phase windings only.
तो you're assuming कि मुझे ये सब आता है, नहीं आता है सर. आप जो बोला डेल्टा क्या है, स्टार कनेक्शन, मुझे नहीं मालूम सर.
Delta will be, delta shape.
Delta shape.
Yeah. Star winding means star.
अच्छा, वो शेप हिसाब से बोला.
शेप के हिसाब से.
हाँ, तो as you said सर, कि वो थ्री फेज है, 1 2 3 है.
Yes.
उसमें जो स्टेटर घूमता है, रोटर घूमता है.
रोटर तो घूमेंगे रोटर, तो रोटर वाइंडिंग्स इज डिफरेंट अगेन. तो स्टेटर वाइंडिंग्स विच कैन बी इधर स्टार कनेक्टेड और डेल्टा कनेक्टेड.
तो वो जो घूमता है तो जो इंडक्शन होता है,
हाँ जी,
तो वो पहले इसको होगा, फिर इसको होगा, फिर इसको
यस,
सीक्वेंस में होगा.
सीक्वेंस पे.
तो कभी पीक में आएगा, फिर जीरो होगा, फिर वापस
जीरो,
आएगा,
यस,
peak में आएगा. वही है ना.
एग्जैक्टली, दैट
तब
विल
एसी बन गया.
एसी बन गया.
नहीं तो सीधा एक ही पे कंसंट्रेट करेंगे तो डीसी होना था. राइट सर.
DC means actually there should be only one winding.
हाँ वही तो, वही मैं कह रहा हूँ.
Then
एक ही पे कंसंट्रेट करेगा, बाकी
Yeah.
पे ध्यान नहीं देगा, तो डायरेक्ट में जा रहा है. वापस घूम घूम के नहीं आ रहा ना.
नहीं आ रहा है,
घूम
नहीं
घूम
आ
के आ
रहा
रहा है बोल के वो जीरो, मैक्सिमम जीरो, नेगेटिव ऐसा आ रहा है.
है. यस यस,
सही बोल रहा ना सर.
सही.
ना मैं कंफ्यूज कर रहा हूँ लोगों को.
नहीं नहीं, एक्चुअली देयर कुड बी सिंगल फेज ऑल्सो. सिंगल फेज ऑल्टरनेटिंग करंट भी होता है. बट हाउ टू एक्सप्लेन दिस? See, what we do is normally, see, I want to tell you one more thing. Any electric machine, generator for example, whether it is DC generator or AC generator, they will produce alternating current only or alternating voltage only. But in case of DC generator, we use a device called commutator. Commutator. Commutator means that will make the DC AC as DC. Commutator is just like split the voltage, so that one half, negative half of the alternating current, that will be actually clipped.
Oh.
So only positive half cycle will remain.
Okay.
Yeah, in the I mean, if we use commutator, so that's why. Yeah,
but it's still not direct, no sir.
No, that is still direct.
That is still direct.
It is the
Okay.
See, zero crossing is the benchmark.
Okay.
If there is a positive half cycle and negative half cycle, that will be alternating.
I agree, sir.
Yeah, but if there is no negative half, only positive half is there, so that will be always a DC.
It will be considered DC.
It is DC.
Need not be a straight line, but
Need not be a straight line. Exactly.
Okay.
So actually, commutator is doing the job of a rectifier in electronic circuit. You must have heard of rectifier and inverter.
मैं बोल रहा हूँ आपको, मैं परेशान कर रहा था.
No. So no, that's fine. So commutator will work as a rectifier. Rectifier means it is used to convert AC to DC, right? So in rectifier circuit also, many a time the output is not a straight line. There will be some ripples. I mean, these pulses.
Understood.
Yeah. So
but negative वाला नहीं है.
But negative will not be there. Negative half cycle is clipped. So, but still there will be some ripples, which can be fine-tuned by using filter, RC filter, resistor and capacitor filter. So that's how. So even the output of a commutator, it may not be a straight line, but it will give a DC output.
It will not be a straight line, but it will be a DC current.
It is a DC. So that's what I was trying to tell you. Any electric generator, whether it is AC generator or DC generator, the output is always alternating. But using commutator, in case of DC generator, we get DC output.
All right, sir. So हम hydroelectric power plant से वोल्टेज जमा किया, वोल्टेज को ट्रांसमिट किया स्टेप अप करके, एज यू सेड 11 केवी से 440 केवी तक भी लेके जाता है.
इट कुड बी इवन 33 केवी, 132 केवी, 220 केवी, 400 केवी.
यू सेड ट्रांसमिशन लाइन, राइट?
ट्रांसमिशन लाइन, यस.
तो ट्रांसमिशन सिस्टम like power grid is a transmission system, right?
Yes. Power grid is looking after the transmission, power transmission.
तो power grid जो ट्रांसमिशन सिस्टम है, ऑर्गेनाइजेशन है, उससे डिपार्टमेंट ऑफ पावर स्टेट गवर्नमेंट का कैसा पहुंचता है? लाइक क्योंकि डिपार्टमेंट ऑफ पावर इज डिस्ट्रीब्यूशन सिस्टम. इट इज
no डिपार्टमेंट ऑफ पावर एक्चुअली, यस, राइट.
मन घर तक तो पावर डिपार्टमेंट में पहुंच जाता है.
दैट इज डिस्ट्रीब्यूशन लाइन अगेन.
दैट्स व्हाट डिस्ट्रीब्यूशन.
यस.
तो जनरेशन हुआ,
ट्रांसमिशन हुआ,
फिर डिस्ट्रीब्यूशन हुआ.
सी वी हैव इन निर्जुली, फॉर्चुनेटली वी हैव वन switchyard.
switchyard क्या होता है?
Powergrid switchyard. Switchyard means there will be a transformer. So I think 220 kV is coming, kilovolt transmission. That voltage is coming to Nirjuli.
मतलब आप जो बोला था कि वो वोल्टेज को लेके उठा के मतलब ट्रांसफर करना पड़ता है,
ट्रांसमिट करके
तो वो उठा के यहाँ पे जमा हो रहा है,
निर्जुली स्विच यार्ड में
जमा
आ
हो
रहा है फॉर
अच्छा।
एग्जांपल, तो उसको स्टेप डाउन कर रहा है यहाँ में, यहाँ क्योंकि हाई वोल्ट 220 किलो वोल्ट दैट कैनॉट बी डिस्ट्रीब्यूटेड ना, सो दैट हैज़ टू बी स्टेप डाउन, सो that is step down to 33 kV, and 33 kV is further step down to 11 kV, and that's how we are getting power from this power grid. And then Nirjuli Department of Power also has one switch yard where 132 kV is step down to 33 and 33 is step down to 11 kV. That's how NERIST is getting 11 kV line, Doimuk also, Naharlagan also. So it is distributed from here.
So और conceptually समझने का try करेंगे. Power grid you said 220.
Yes. 132 to 220 this voltage level will be of
तो
that range.
power grid का जो step down switch yard है,
Yes.
और usually power डिपार्टमेंट का भी है, दोनों में ज़्यादा फर्क नहीं है ना, तो फिर
ज़्यादा फर्क means the voltage level will be high
वोल्टेज
in the power grid.
लेकिन जो फंक्शन है,
Functioning operation is same.
Same, you know.
Yeah, either you should step up or step down. For distribution, it is usually 11
kV. Power is
kV.
not distributing, no.
No. It is terminating their supply to this Nirjuli switchyard, which is of Department of Power.
Oh, that's what.
Yes.
मतलब power grid is not supplying us
Directly. No.
वो सामने जो पड़ोसी है उसमें दे रहा है.
Yes.
Nirjuli power department.
If you have visited this Babita store or some this side, there is one switchyard of power department also.
देखा है.
Government of Arunachal Pradesh. So there 132 kV is stepped down to 33 kV, and then further for distribution 33 kV is stepped down to 11 kV.
So when it is being stepped down,
yes,
does it mean that कि बैकअप मतलब स्टेप डाउन का फिजिकल डेफिनेशन क्या हुआ, मतलब
no, step down means only the voltage level is reduced. Yes.
तो रिड्यूस क्या का मतलब माइनस नहीं किया ना,
माइनस नहीं किया
टोन डाउन किया,
टोन यू कैन से दैट.
मतलब ऐसा नहीं कि 33 से 11 दे दिया तो बाकी और 22 और बचा, ऐसा तो नहीं है ना.
नहीं दैट इज टेकन केयर ऑफ बाय द ट्रांसफॉर्मर्स, पावर ट्रांसफॉर्मर्स.
और ट्रांसफार्मर क्या होता है सर?
Transformer is a device which step up or step down the voltage levels.
अच्छा वही करता है.
That is the job of transformer.
Okay. तो सर जब रिक्वायरमेंट ही 11 kV का है फाइनल नेरिस्ट में,
Yes.
11 kV ही क्यों नहीं?
I was telling you usually generation of power at the generating station, it is usually 11 kV. That is stepped up to 33 kV or 132 kV. Then it is transmitted.
Oh.
See, the point is, if it voltage level is low, then in the transmission line the losses will be more. Suppose you try to transmit power from here to, let's say, 0 at 11 kV. Then suppose here the sending end voltage is suppose 11 kV. When you try to find out the voltage level at 0, that will not be 11 kV. It will be much below that because there will be losses. So in order to overcome this, voltage is generally transmitted at high voltage, so that at the receiving end you get the rated voltage that you are looking for.
I got my answer sir. मैं वही सोच रहा 11 ही था एंट्री में, एग्जिट भी 11 है, बीच में नोटंकी क्यों चल रहा है? मतलब लॉसेस होता है.
Yes. Losses are power losses.
What are the losses sir?
Losses are usually copper losses will be there.
So what is that?
Copper means because transmission line has got
कॉपर मेटल यूज करते हैं ना.
copper or aluminum.
हाँ.
So usually they are metallic. They are conductors.
They are conductors.
So there will be various losses actually. Voltage drops could be there. Then see, if we go in detail, then there are so many things involved in this. So losses will be there. There are corona effect also. So many things. So ionization of wires or the conductors.
Corona effect क्या होता है sir?
Corona effect will be some kind of discharge. See, as I told you, when a conductor carries current, so there will be magnetism around it.
It is established, correct.
At such a high voltage, for example, 132 kV or 220 kV, so around each conductor there will be electric field also.
Very strong.
Around that. So because of that, actually ionization takes place.
Yes.
And that formation of ionization itself is called corona effect.
Right.
So there could be hissing sound also. Sometimes you can hear that also.
Yeah, yeah.
In a very high voltage transmission line.
That is because of the ionization, right?
Yes, if you stand below those transmission lines, you can hear that. Usually towers are used to transmit the power. You must have seen all along this national highway, especially you'll find.
So there are two purposes, as I've understood, for
Yes.
the very tall towers.
Yes.
First, for safety of the...
For safety, usually because these conductors, for high voltage transmission or long transmission, we use ACSR, we call it ACSR, aluminum conductor, steel reinforced. So in between the conductors, there will be steel also reinforced that will go all along the transmission line.
Is it for structural purpose?
No, that is for strength.
That's what
strength.
Structure,
yeah.
Strength only.
Otherwise, between two towers, usually you'll find there will be sagging also, sagging of conduct. So if you pull it too tight, then conductor can also break.
Snap off now.
Yeah, snap off. So to support that, usually there will be still reinforced.
तो सर जनरेशन से लेके ट्रांसमिशन से लेके अभी डिस्ट्रीब्यूशन से लेके अभी घर तक पहुंचते हैं सर एज यू से द लोड बोले हैं ना आप बल्ब को
यस इलेक्ट्रिकल लोड
आप ये बताइए तो सर लेट्स से दिस ट्यूब लाइट हैज 40 वाट ट्यूब लाइट कहते हैं
यस
ये 40 या 10 है
ये नाउ दिस इज 40
हाँ तो बल्ब जो 60-100 होता था
यस पहले
कम रोशनी मिलता था इन हायर पावर कंजम्पशन बोर्ड में इसका थोड़ा सा साइंस बता दीजिए
एक्चुअली दोस इलेक्ट्रिक बल्ब्स वी यूज्ड टू कॉल दे आर फिलामेंट बल्ब्स inside the bulb you will find there will be a thin wire tungsten filament so that works on the principle of heating effect of electric current
just like electric heater
Ooh. Exactly. Achha. So because of I square R loss that is loss only actually power loss only but that gives rise to heating effect
resistance ज़्यादा है
resistance is very high tungsten the resistivity is also very high
तो वही मतलब flow of electrons को resist कर रहा है इसलिए वो
गर्म हो रहा है and that glows basically
गर्मी का वजह से
yes so that was the concept for old bulbs nowadays we have CFL compact fluorescent lamp
वो क्या साइंस क्या है सर
neon bulb also
टेक्नोलॉजी सर बताइए ना
उसमें CFL में there are some chemicals are used inside actually. Achha. So because of ionization is taking place actually. Right now I'm forgetting the powder or the component compound.
That's fine.
Yeah.
But ionization happens.
Ionization happens and because of that it glows actually.
और वो इतना गर्म भी नहीं होता ना सर
गर्म भी नहीं होता है
रेजिस्टेंस नहीं है अब उतना लेवल का नहीं है जो कोई
टंगस्टन वाले उसका नहीं उसके जैसा नहीं है ये
तो इलेक्ट्रिकल का पूरा ट्रांसमिशन से घर तक पहुंच गया सर सर एनर्जी जो टर्म है ना
यस
एनर्जी कैन नाइदर बी क्रिएटेड और डिस्ट्रॉयड ऐसा बोलते हैं
यस
समहाउ इट्स अ साइंटिफिक टर्म भी है थोड़ा स्पिरिचुअल टर्म भी लगता है जब बोलते हैं नथिंग कैन बी क्रिएट आई मीन समथिंग दैट इज कैन नॉट बी क्रिएटेड नॉट बी डिस्ट्रॉयड समथिंग इट इज क्वाइट एटर्नल
यस
इट्स फॉरएवर इट्स बियॉन्ड स्पेस एंड टाइम स्टफ तो energy is a term associated mostly with electrical engineering.
Yes.
क्योंकि मतलब हम बिजली को एनर्जी समझते हैं.
Yes.
इस पे आपको कुछ कमेंट सर?
Energy actually especially in the present day is very important, very crucial. We should say per capita energy consumption is an index how developed a country is. Because if we consume more and more energy, that indicates that there are so many industrial activities taking place.
Okay.
So that in turn we can say production is happening. So industries, so many industries are active. So that means economy is supposed to be better.
Correct.
So that is why per capita energy consumption indicates how developed we are. So that's why we cannot compare the per capita energy consumption of India and US. They are much ahead of us. So, but still, we are also developing slowly. So, energy as such, nowadays synonymous with how developed we are actually. Then again, when it comes to energy, because the conventional sources of energy, they are depleting fast. For example, coal-based thermal power plant. Then
Fossil fuels and all. Right?
for fossil fuels, or whichever requires fossil fuels. So we are not, they are not sustainable actually. So we are that's why we are moving towards renewable sources of energy. And wind and solar, they are very popular. And they are being extensively harnessed in India as well. So,
Sir, when you say wind energy,
yes.
wind energy and hydro energy, I think the purpose is same, right? Rotate the generator.
Yes, turbine generator.
वही है ना
Yes,
सर, हवा
yes.
से घुमाओ या पानी से घुमाओ,
पानी से घुमाओ.
लेकिन सोलर एनर्जी तो अलग ही कॉन्सेप्ट है.
Solar energy is totally different. Yeah.
उसका टेक्नोलॉजी सर, क्योंकि आप अभी विंड एनर्जी बोलो या टर्बाइन एनर्जी जो अभी आपने
Yes,
डिस्कस कर लिया,
yes, yes.
रफली सेम ही है.
Yeah.
सोलर एनर्जी का सर क्या होता है सर?
Solar energy का ऐसा है, we have solar PV modules available. Solar photovoltaic. Solar photovoltaic modules are available, and solar cell works just like a diode. Diode in electronic circuits you will find. So in solar cell also there are P-type region and N-type region will be there.
सर ये टेक्निकल हो गया, फिर वही थोड़ा मतलब आप समझ लीजिए 10 साल का बच्चा से बात कर रहे हैं.
So solar cell works on the principle of photoelectric effect. Photoelectric effect. Many people confuse it with photovoltaic effect. That is wrong. It is photoelectric effect. So what happens is when solar radiation means it carries photons, photons with it.
Taken.
Yeah. So PN junction, this I think I have to tell this. P means positive actually, N means negative. So neutrons will be actually sufficiently available on N region, negative region you can say.
Okay.
Then P-type region there will be holes. Holes is positively charged actually. So what happens is when photons falls onto the N region where electrons are available. So then that photons with sufficient energy will actually when it strikes onto the N region of the solar cell, it will basically how to say, the electrons will be emitted, and that will try to, if we provide a closed circuit, that electrons will try to flow to the P region, where holes are available and positively charged. So that's how these electrons will keep moving from N region to P region. So we call it electron hole pair recombination also. So an electric current is nothing but flow of electrons.
Exactly.
Yeah, that's how we are getting a current.
समझ गया सर. वही ये
Yes.
मतलब जब सोलर लाइट पड़ता है, फोटोन जब पड़ता है, जो नेगेटिव एरिया है, जो एन जंक्शन में जो इलेक्ट्रॉन्स पड़ा हुआ है, बहुत ज़्यादा पड़ा हुआ है, उनको मूवमेंट करने का ताकत मिल जाता है, तो मूव करता है, मूव करके वो पी जंक्शन में जाता है, जो खाली पड़ा हुआ है,
पी रीजन में जाता
है, तो खाली पड़ा हुआ है. तो once the motion is there, current is generated. Current is nothing but flow of electrons.
Flow of electrons.
Okay.
So that's how we get current.
अच्छा.
From the solar cell.
तो ये जो solar panel.
And solar panel, as we call it, will have large number of solar cells connected in series.
अच्छा, connected in series. अभी जो बोला एक single unit था, उसको एक line पे खड़ा करते हैं.
And solar cell, the output voltage will be in the order of 0.5 volt. 0.5 volt. Very, very small actually. Single solar cell. So that will produce about 0.5 volt. Now when we connect, suppose if you want to get 18 volt from the panel, solar panel, then 36 cells should be connected in series. And that's why you will find in a solar panel there will be round, so many circular, cells will be there.
Correct.
They are all connected in series so that you get, higher voltage.
सीरीज का मतलब एडिशन ही हो गया.
एडिशन हो गया.
एक के बाद एक ऐड करते हैं. तब तो ये बहुत इजी हो गया टेक्नोलॉजी. I mean it's very convenient, no?
Yes. Then solar array we call it. solar array, solar panel array, that will be, that nothing but a combination of various solar panels or solar PV modules. We call it solar panel array. If you want to get power in order of megawatt and all.
So let's understand this first. You spoke about solar cell,
Yes.
very fundamental solar cell,
Yes.
and you have a maximum of 0.5 volt. If I need an 18 volt वाला तो हमको उसका 36 करना पड़ेगा.
Yes.
वो 36 का एक हमारा पास पैनल है.
एक पैनल
तो
होगा.
वैसे 50 पैनल रखेगा.
50 पैनल रखेगा तो आप कनेक्ट सभी को अगर
फिर सीरीज में करेगा तो फिर ऐड होगा.
ऐड होगा, सारे ऐड हो जाएंगे.
अच्छा. तो उसको एरे कहते हैं.
Yeah, actually in an array, the panels, solar PV panels will be connected in series as well as in parallel. If you connect all the panels in series, you are increasing the voltage. But if you are connecting all some of the panels in parallel, you are increasing the current. So if you want to increase the power, you have to connect some of the panels in parallel as well.
So you repeat sir, थोड़ा सा कंफ्यूज हो गया. मतलब सीरीज में
वोल्टेज विल इंक्रीज,
लेकिन अगर
पैरेलल करेंगे तो करंट इंक्रीज हो जाए. हाँ.
अच्छा. तो कॉम्बिनेशन दोनों.
कॉम्बिनेशन चाहिए दोनों का.
अच्छा.
And in solar, this solar panel array, we also use some blocking diodes as well as bypass diodes.
फिर ये सब नहीं समझ में आ रहा.
हाँ, blocking diode क्या होता है? Actually, solar panel, you can understand when the solar radiation is there, as long as sun is there, sun rays are available, they will convert, they will produce electricity. But in the dark, in night, for example.
Absence of photons.
Yes. So sometimes the panel itself can work as a load, electrical load. Because solar.
एक सेकंड. इलेक्ट्रिकल लोड मतलब
बल्ब
या कुछ भी.
कुछ भी. No, see, actually, solar PV system, we always need a storage battery, no? Because that energy, whatever is
stored,
derived from the sun, that has to be stored in the form of chemical energy. That is solar lead acid battery, you can say. So the battery will be charged so that you can use that electricity in the night. So what happens is, if you don't use this blocking diodes, sometimes there will be self-discharge. In the night time especially, because there is no solar radiation available.
Self-discharge doesn't mean कि self loss हो रहा है कि वो खुद
self-discharge means the battery will get discharged. So because these panels will act as a load.
हाँ, उस पे ही खर्चा होगा बैटरी.
उस पे खर्चा होगा. So blocking diodes are used. And also, as I said, bypass diodes are also used.
Sir, ये diode का simplistic meaning क्या होगा?
Diode is a switch basically.
Switch.
And then it will allow the current to flow in only one direction.
ये मैं सवाल आपको पहले पूछना चाहिए था, मैं फिर सोचा.
Diode will, and it will never allow current to flow in reverse direction. Yeah. So that's why bypass diode is also used.
Basically, they are direction control valves kind of stuff.
Yeah, actually what happens is, suppose you have a solar PV array, and if one of the arrays, if it comes under a shade, for example, trees could be there, so that will become, actually the current will now start flowing backward. It will negate all the voltages generated actually. So
discharge का concept यहाँ पे भी आता है.
Yes. So bypass diodes are used so that even if one module or panel or array comes under shade, so that will be bypassed, so that current will not flow back.
Okay.
It will flow through that diode and then move on to the next panel. So that is bypass diode.
Bypass का meaning literally वही meaning है.
वही
It will
meaning
bypass जो काम नहीं कर रहा है, ताकि वो discharge activate ना हो जाए.
Yes. The reverse flow of current.
हाँ, वही reverse flow of current.
Yes, that will be taken care of.
सर बाप रे. सोलर का बारे में मालूम हो गया. Wind और hydraulic तो पता ही था सर. So any other renewable energy form you want to speak about, sir?
Yeah, one thing I want to tell is, see, we are going in a big way to harness renewable energy sources. It could, whether it is solar or wind. But wind energy, actually, as you know, that wind, the flow of wind is not constant.
It is not.
Sometimes it could be the wind speed could be very low. Sometimes it could be high. So what happens is, invariably in a wind energy application, we use AC-DC AC converter. So that means, see, if we directly try to tap the voltage generated from a wind electric conversion system, we call it WECS, wind electric conversion system. So if we directly try to tap, that voltage will be variable. Okay. Also the frequency will be variable.
It is completely understood.
Yes.
It depends on the speed of the fan.
Speed of the
blades.
So what we do is we use because the voltage produced will be AC definitely. But that is why we use AC, then we convert it to DC.
Okay.
So that frequency also becomes zero.
Sir, so solar का बारे में जितना भी डिस्कशन हुआ मुझे तो समझ में आया सर, अच्छा से आपने बताया. सर रिन्यूएबल एनर्जी का बारे में आई थिंक यू शुड स्पीक मोर बिकॉज यही चाहिए ना हमें, तो बताइए सर और कुछ.
Okay, yeah, I was telling actually regarding wind energy, because we are using AC DC AC converter. These are all power converters. Power converters means using solid state devices. For example, thyristor, then IGBT.
इससे फिर वर्ड यूज करेगा तो फिर मुझे समझ में नहीं आएगा.
Okay, so I mean there is a power converter where we are using solid state devices, power electronic devices. So then in case of solar energy also we are using DC AC converter.
That is understood.
Yeah, because voltage generated from solar PV panels, they are DC only. Sir. But all the household domestic appliances they need AC.
Sir, when we speak about wind energy,
yeah,
because wind is not constant, sir.
Yes.
तो जो motion of the so-called blades है वो कभी भी constant RPM में तो होगा नहीं, sir.
Yes, yes.
तो फिर उसका क्या जुगाड़ है, sir?
उसका actually wind energy conversion system could be geared type as well as gearless type. Geared means we can use speed increasers, for example. If the wind speed is low, then we can use a gear system so that the speed is increased to the rated value. See, the most important thing is actually frequency. You know that power system in India, we use 50 hertz. If the frequency is less than 50 hertz, that is of no use. And it should not be higher than 50 hertz also.
Why 50, sir? I don't know, sir.
No, 50 is the standard for Indian system, electricity system. For example, USA, it is 60 hertz.
Oh.
See, if you want to test it...
It is policy based, no, sir?
It is policy based, yeah, because all our appliances, devices are also designed accordingly.
Oh,
yes.
Okay. All the made in India products.
Yes, yes.
Made for India products.
Made for India, it is 50 hertz.
Okay.
And to see its effect, the frequency effect, we were talking about that incandescent lamp. That means filament lamp. So if you try to give a supply to a filament lamp at a lower frequency, say 30 hertz or 40 hertz, the lamp will glow, then it will become dim, glow, dim, and that changes will be slow. But if you increase the frequency beyond 50, the bulb will
blink.
It will flicker. Yeah, but at 50 hertz, it will be a stable light you will get. So
ये output तो समझ में आया. इसका science क्या है, sir? मतलब
science is actually, see, that is absolutely variation of the alternating current or voltage.
Okay.
See, if you allow the voltage to vary fast, then that will affect actually. That is also optimized. So
understood, sir.
Yes. So usually if frequency is equal to 1 by t, time period.
एक second या एक unit time में कितना बार
so if you want to get 50 hertz frequency, then time period should be 0.02. T equal to 1 by f, na? 1 upon 0.02, so that will be 50.
Correct.
Yeah. So so I was telling
wind
energy. Why I mentioning this? Converters are used. Again in solar PV system, converters are used. They are all DC to AC, and in this case AC to DC first, then again AC. So we are using this power electronics devices basically, and which has its own rated power. For example, IGBT, or say silicon control rectifier. They will be using this SCR or thyristor, which will have its own ratings: current rating, voltage rating, power rating.
So इतना technical term use किया.
No, actually, I'm trying to explain why. I'm telling this because the output of these renewable energy sources finally is coming from these power converters. I mean, electronic circuits, you can say.
Solid state devices जो आपने बोला.
Solid state devices, yes. So, but the conventional power that is being generated by hydro or thermal, they are using alternators, as I said. So alternators mean generators, which is a rotating machine.
Because sir, well, the rotation of the blades can be controlled there, no?
Yeah, but see, okay, I was telling one could be geared system, the other one could be gearless system. So for gearless system, nowadays, the widely used generators are induction generators. Okay. So induction machines are usually motors, induction motors. But nowadays, because of for wind energy application, induction motors are converted to induction generator. The induction motors are made to work as a generator. Okay. So induction generators are variable voltage and variable frequency generators. Okay. So in a gearless system we can use that.
Variable wala.
Yes, but then the output will again come from this power converters only.
The output will be the desired rated, but input can be variable.
Input can be variable. Yeah.
Input will be variable for wind energy.
It will be. So what I'm trying to say is conventional power plants, they are using rotating machine, synchronous generator or alternator, or simply generator you can say. So what happens is, if there are so many generating stations, and in a single generating station, I told this before also, it will not be only one unit. There will be 2-3 units at least. I'm told this Lower Subansiri that
Dipco.
No, Gerukamuk.
Gerukamuk.
Yeah, that one is having 8 units. That is what we are told. NHPC. Yeah. So all these generating units will be connected in parallel. So we are talking about only one power generating station. There's so many in the country. Correct. North, south, east, west, northeast. Yes. So what happens is, if we are, because of penetration of more and more renewable energy sources, say wind or solar, the output power is connected to the grid.
Grid means?
Grid means there's a national grid actually. Grid is nothing but interconnected system. Okay. Throughout the country, there's a national grid, and national grid means zone-wise also. Okay. Northern zone, south, east.
It's like analogous to server.
It is a network. Power network. So we are pumping the power generated from renewable energy sources to the grid, as well as from the conventional power plants. And what happens is, conventional power plants, they are using, as I said, rotating generators. So the beauty of rotating synchronous generator or alternator is that it will have inertia.
Yeah, it will have.
It will have inertia, yes. Then also it will have this synchronous impedance, we call it synchronous impedance of each machine. So what happens is, when they are connected in parallel, conventional sources, because we have a rotating machine, if large number of generating stations using rotating machine, if they're connected in connection will be finally parallel only in the grid level. So what happens is, because of large generating units connected in parallel, it will have lot of inertia. Yeah. So when inertia is very high, let's say infinite, then see this, there's a accelerating torque for each machine actually. So because of loading or unloading, there will be some torque developed. Because you must have seen, whenever a generator is connected to load, even genset, the sounds you'll find a difference in the sound. So that is happening in actually alternators also. So momentarily there will be some accelerating torque, and whenever torque is, there is a kind of oscillation. Then the frequency gets affected actually. So frequency could be sometime below 50 or maybe above 50 also. So, but because we have so much of inertia, that oscillation is actually controlled because of rotating machine in the conventional power plant. So frequency will be maintained. Yeah. Second aspect is with the conventional generating system, when a large number of generators are connected in parallel, the synchronous impedance of each generator, their impedance is just like a resistance. So because it is synchronous machine we are talking about, so it is synchronous impedance. So that will be very, very small. So that means the voltage generated will be always equal to the terminal voltage. Actually, it can be explained using a relation, small relation, but it's okay. What I'm saying is, if the impedance, synchronous impedance become very, very negligible, then the generated voltage will always remain constant. So that is the idea. So this is one aspect of conventional system. But using renewable energy sources, we are using all power electronic switches, devices. So what happens is, this inherent quality of rotating machine, like inertia and then synchronous impedance, these are missing. So what happens is, these power electronic switches or devices, they have their rated values of current, voltage, power. So if that is exceeded, there can be blackout also. So what I'm trying to say is, if we use more and more renewable sources of energy in future, the grid will be inverter dominated grid, which is not good. Yeah. So this is one aspect. I think people are doing a lot of research also.
This is so different from what the conventional narrative is.
Yes.
Right, sir?
Yeah. So this aspect we have to actually we should research upon also.
ओके दिस इज इंटरेस्टिंग सर ये एक नया डायमेंशन खोल दिया मैं सोचा आप कुछ और बोलते रहेंगे एंड में जाके ऐसा बोल दिया
That's why I was talking about renewable energy, these converters, power converters.
So I'll try to review what you said. Maybe just for you to understand if I've understood anything. You said that in the conventional power generation system, because these are all based on rotation of the let's say
Rotating machines.
Rotating machines only.
Yeah.
All these conventional ones,
Yes.
hydropower, hydroelectricity हो या फिर thermal power plant हो. So rotating machines है तो because of the rotation there's a inertia developed.
Yes.
And when you connect all these generators in parallel and too many in numbers, so the inertia is almost infinite.
Yes.
And because of the infinite inertia जो एक developed torque होता है,
Yes. Oscillation
होता
of
है
the
जो
generator.
disturbing एक factor
which
होता
can
है.
disturb the frequency.
It will disturb the frequency. As you have said, 50 hertz is the frequency, which can disturb the frequency.
Yeah.
Is being controlled because of the inertia. It is regulated there. तो ये हमको एक added advantage एक तो,
Yes.
right sir?
Yes.
और दूसरा आपने जो बोला कि because of this inertia, so called let's
No, the other aspect is impedance.
हाँ वही जो रेजिस्टेंस होता है, इम्पीडेंस जो होता है ना, उनको भी कंट्रोल करता है. तो हमको वोल्टेज जैसा टर्मिनल वोल्टेज है वो वोल्टेज हम मेंटेन कर सकते हैं. बेसिकली जो इनर्शिया का जो खेल है ना, ये बहुत को कंट्रोल में ला रहा है. वो इम्पीडेंस को भी कम कर दिया और वो एक्सेलरेटिंग टॉर्क को भी कंट्रोल में ला दिया.
Impedance is lowered because of a parallel connection of large number of machines.
I mean, this is taken कि structurally they are parallelly connected and too many large number of generators put together, right sir?
Yes.
Okay, ये है फायदा है हमारा conventional power system का. Then we are speak about renewable energy sources of power generation because अभी ये buzzword है and people are working on that. Now these उसमें तो एक कांस्टेंट इनर्शिया तो होगा नहीं बिकॉज मोशन नहीं होता. वो मोशन को हम रेटेड डिवाइसेस का थ्रू ही उनको कंट्रोल करते हैं, राइट सर?
यस.
तो वो रेटेड डिवाइसेस जो होता है अपना ही रेटिंग होता है. तो किसी कारण से अगर वो उसका रेटिंग से ऊपर नीचे हो गया तो वो डैमेज हो सकता है. इट कैन बी एरर हो सकता है. तो उसमें ब्लैकआउट हो सकता है. तो ब्लैकआउट होगा तो जस्ट इलेक्ट्रिसिटी को मेंटेन करने के लिए इन्वर्टर कॉन्सेप्ट लेके आना पड़ेगा. तो जो आपने ग्रिड बोला था जो नेटवर्क होता है तो अगर प्योरली रिन्यूएबल एनर्जी विदाउट प्रॉपर अगर फाउंडेशनल रिसर्च के साथ नहीं करेगा तो एक्चुअली इट कैन बी detrimental.
Yes, and that is why people are also trying to design a model virtual synchronous machine. That means using electric circuits only in order to, imitate these rotating machines. People are working on that also.
So when you say synchronous, sir, ये तो the terms synchronous literal meaning जो वही है ना, like जो what I understand by synchronous,
It will rotate at a constant speed, synchronous speed.
synchronized speed में चल रहा है ना, और जैसा frequency है उसी हिसाब से rotate करेगा तो it's there actually. आप डैमेज नहीं कर रहे उसको. Understood ना सर मैंने जो बोला?
ठीक समझा.
हाँ थैंक यू सर. ये भी नया चीज़ सीख लिया सर. सर अभी आते हैं ये तो हो गया एनर्जी के बारे में. I really wanted to know the narrative about energy and you have given me and my viewers actually कि exactly क्या हो रहा है ना. Sir, B.Tech in electrical engineering में in Indian syllabus, so what are the subjects, sir?
In B.Tech curriculum, the core subjects are one is electrical machine, then power system, and power system includes actually generation, transmission, distribution, everything. Yeah. Then power electronics. Power electronics talks about all these switches. Switches or solid state devices.
Solid state devices.
Yes. Starting from diode, then thyristor, then
okay.
All those components. Yes. Then control engineering is one core subject. Control engineering.
Like आप ना एक लाइन बताइए कि क्या
control engineering is used many areas. For example, flight. Even helicopter design, it's purely based on control engineering. So it's very, very important subject. And
what does it teach, sir?
It is full of mathematics.
What does it teach, sir? What is the purpose of control engineering?
Control engineering for designing sophisticated equipment, I can say. I gave you an example. Let's say helicopter or flight and aircraft. Control engineering is extensively used.
What is the word?
Precise design of any equipment.
The term control here, what does it connote here? What is being controlled?
No.
To keep things within the range, or what is it?
Yeah, you can understand that way actually.
To maintain things within the range.
Precision.
Precision.
It talks about precision actually.
Okay.
Yeah.
Get it. Whatever is the required value. Threshold. Maintenance
optimized way.
So control engineering done, sir.
Then measurement, instrumentation. This is another subject. Yeah.
So
then microprocessor, I was telling.
Microprocessor.
Yeah, correct. That is partly electronics and partly electrical. It is programming is done on that, and using that precise control again we can achieve. Electric motor drives also we can control using microprocessor. So this is another subject that is taught to UG students, B.Tech students.
Sir, for M.Tech, what are the specializations?
There's so many specializations. In fact, control and instrumentation is another area. Then power system. Then
power system would mean all those things.
Power system means all this transmission, generation, and then again control engineering is also coming.
Okay, so everywhere. No?
Everywhere, yeah. So these are then electric power electronics and drives. So again control of drives from by this electronic circuits. Yeah.
And renewable energy to hoga hi na, sir?
Energy is also another area.
Non-conventional renewable energy.
Non-conventional energy system means both conventional and non-conventional will be taught. And, these are the areas.
Sir, आपका research.
Yes.
किधर था sir? आपका. If you could recall your B.Tech project, sir, can you speak about that?
B.Tech project was on I remember that was single phase inverter, design of a single phase inverter.
Was it a novel technology at that time?
Sorry?
Was it a novel technology at that time?
It was.
Okay, we are talking about 80s, late 80s or early 90s.
Yes, because inverter circuits using solid state devices, power electronics. So we had done a lot of drawings and some calculations. like that actually. And the project, that dissertation, that copy was also typed in typing machine.
Typewriter.
Yeah, typewriter.
Acha.
Yes.
How many friends you had, like project mates?
Project, we had 3 of us.
Where are they now, sir?
Yeah, actually, both of them are doing very, very well. One is in Powergrid itself, and he's a senior general manager. Then other one is also a general manager, again in Powergrid. Both are from
So they
zero.
have taken the core,
Yes.
domain only, right?
Yes.
Power grid, and you have taken academics.
Yes.
Interesting, sir. So M.Tech project, sir.
M.Tech
And what was your specialization, sir? M.Tech.
M.Tech, my specialization was on alternate hydro energy system, but my project was on solar photovoltaic again.
Oh, तो आप renewable energy में काम किया.
Yes, solar photovoltaic, techno-economic study.
Economic study.
Yeah, techno-economic.
वो क्या होता है techno-economic?
Techno-economic means whether solar PV system could be technically viable. I mean, economically viable or technically feasible.
आप तो IIT रूरकी से किया ना सर?
IIT Roorkie से
वो
किया.
तो हाइड्रोलॉजिकल कैपिटल ऑफ इंडिया बोलता है. वहाँ तो आपको
Yes.
एक्सपेरिमेंट करने भी बहुत मिला होगा.
In fact, NIH is also there, National Institute of Hydrology.
Correct.
It is in almost the same campus only with IIT Roorkie. So, yeah, we had done a lot of, for example, micro hydro was my specialization actually. So, we had done a lot of work on that. Then, my PhD work was on induction generator. Induction generator, when we say it is, as I said, induction machines are generally motors. But we are making that motor to work as a generator. So induction generator itself is it's a new term. Yeah. Because early days, this induction machine means it is drives. That means motors. So, but people are experimenting with the same machine to make it work as a generator. And in fact, I worked on a self-excited induction generator. That was my thesis. My thesis was
self-excited.
Yeah.
How does one?
Self-excitation means actually any induction generator. The basic requirement is looking at the torque slip characteristic. If we rotate if we allow the rotor speed to be higher than the synchronous speed, then that induction motor will work as a generator.
Okay.
Yeah, it can be explained through torque slip characteristics only. But anyway.
No, it is understood.
Yeah.
Synchronous का जो उसका अपना कुछ फ्रीक्वेंसी रहेगा ही, कितना एक टाइम पे कितना बार घूमता है.
Yes.
उससे स्पीड ज़्यादा होगा.
उससे स्पीड ज़्यादा होगा
तो
वो जनरेटिंग मोड में चला जाएगा.
जनरेटिंग मोड में चला जाता है.
Yes. Suppose sleep is 1. Sleep is the difference of synchronous speed and rotor speed. In layman's language. So if sleep becomes more than 1, it will go to braking zone. No?
Correct.
Yeah. Yes, so now we can say that if sleep becomes negative, then it will go to generating mode.
Yes.
That is one requirement to make motor as a generator, induction motor. Then another requirement of induction generator is reactive power. It requires a reactive power. That means excitation current, you can say, or excitation power. So that reactive power could be obtained either from grid or
did you spoken?
Yeah, because any grid will have active power and reactive power both. They will always be present in any grid system. So that could be either obtained from grid reactive power from grid, or using a capacitor bank. Also reactive power could be provided. So I used capacitor bank. So it was that is why it is also called standalone mode of operation of induction generator, because if it is grid connected, then we have to always connect it to the supply side actually.
Capacitor क्या होता है फिर sir?
Capacitor is nothing but it's 2 plates, and in between you need this dielectric medium. So when you charge it, it will store energy. The capacitor will store.
That's it.
And dielectric material could be even paper. Yeah, so that's the capacitor.
Okay, sir. I think we have hit the, I don't know, 1 hour mark, roughly. So before we wind up today's conversation, I need your opinion on a thing called electric vehicles, sir, because it is in operation and purchase these days. Especially in China, it's, like most of the taxis are electric vehicles only. So India में तो अभी तक इतना नहीं आया है, आने वाला है. Comment कीजिए ना sir.
Electric vehicle, it is no more a myth. I think it is
In operation.
in operation, and to a great extent, it will reduce the pollution definitely, because we are using fuel nowadays, whether diesel or petrol. They are highly
Carbon footprint बना रहा है.
Yes.
PPM बढ़ा रहा है.
yes बढ़ा रहा है. तो electric vehicle, I think it is will be very very useful. And
How does it work, sir?
it has the main component is electric motor only.
वही है ना जो fundamental
Yes,
बात है.
yes, it's a motor. So I think induction motor could be also used. Then DC motors are used. Then there's so many even reluctance motor are being tried. So it's an electric motor basically. So supply will come from battery.
तो battery
will
has to be
drive.
charged. That's all. So
It
how
has
does
to
the
be
battery work, sir?
Battery,
हाँ.
lead acid battery, for example.
हाँ कैसे काम करता है ना?
No, lead acid battery will have a, see, the fundamental theory is again electrolysis. Electrolysis process, if you remember.
I remember.
Yes.
फिर बताइए sir. लेकिन
Yeah. See, electrolysis process is nothing but there will be anode and cathode. That means positive plate and negative plate. And there should be electrolyte. And that should be immersed in an electrolyte. No? So what happens is, if you give supply to that, for example, we can think of copper sulfate as a electrolyte. Then when we give supply to that terminals of the electrodes, then that there will be dissociation of ions. Then copper will be positive and sulfate will be negative. So that will copper will be deposited on the
one of the terminals, right?
Yeah, one of the terminals. Yes,
दोनों जाएगा
there
अपना
will be
बदलेगा.
dissociation and that will get deposited. So finally, actually, that will be charged.
Charge हो गया.
Charge हो गया. So similarly, in case of lead acid battery.
So when the battery is being used, sir, तो फिर क्या होता है? फिर चार्ज हो चुका है, अभी फिर इसको use करना
Yeah,
है.
then they should be used for any type of load.
नहीं वही तो उसमें क्या चलता है? फिर वो वापस जाना शुरू करता है.
Yes, वापस जाना शुरू करेगा मीन्स एक्चुअली ऐसा है, वो उसमें जो एनर्जी स्टोर किया है, पॉजिटिवली चार्ज हो गया, एक नेगेटिवली चार्ज हो गया. And in case of battery, as you know, you have to follow the same terminal. Positive terminal should be connected to positive terminal of any load. Same electric motor, for example, DC motor, it has to be connected there. Negative terminal to similarly to the negative terminal of the motor, for example. So then it will derive energy from the battery, stored energy. So in case of lead acid battery, the electrolyte is actually dilute hydrochloric acid, H2SO4. So hydrogen ions and sulfate ions again will work as similar to that copper sulfate only. That's how charging and discharging is happening.
हर बैटरी का यही concept है.
यही concept है.
Any battery.
Any battery.
ठीक है sir. Sir, I want you to look at that camera and encourage students to take up mechanical engineering. जो
Electrical or mechanical?
Oh sorry, I'm sorry. थोड़ा bias हो गया sir. Electrical engineering उसका क्या क्यों लेना चाहिए और उससे क्या आप humanity को आप contribute कर सकते हैं being an electrical engineer?
Yeah, I would like to tell the viewers that electrical engineering is a very interesting subject. Those who are good in physics, chemistry, math, they should definitely go for electrical engineering. And we deal with electrical circuits, electrical voltage, current waveforms. That should be very interesting. And especially nowadays, we use so many tools, and then there are so many equipment which displays the voltage waveform, current waveform. By seeing that itself, you'll find it very interesting. And also, electricity or energy is, one cannot stay away from. So when you enter into electrical engineering, you will get to study about energy system, which is very interesting. You can explore renewable energy, sources of energy, and do much more in the area. So with this, I want to thank Dr. Tay, and thanks to all the viewers.
So thank you very much. I learned a lot today, and I'm sure my viewers also learned. Thank you, sir.
Thank you.